Example 1. Coins were discussed in previous lessons of this module. What is special about a coin? In most cases, a coin has two different sides, a head side, heads, and a tail side, tails. The sample space for tossing a coin is heads and tails. If each outcome has an equal chance of occurring when the coin is tossed, then the probability of getting heads is 1/2 or 0.5. The probability of getting tails is also 0.5. Note that the sum of these probabilities is 1. The probabilities formed using the sample space and what we know about coins are called theoretical probabilities. Using observed relative frequencies is another method to estimate the probabilities of heads or tails. A relative frequency is the proportion derived from the number of observed outcomes of an event divided by the total number of outcomes. Recall from earlier lessons that a relative frequency can be expressed as a fraction, a decimal, or a percent. Is the estimate of a probability from this method close to the theoretical probability? The following example investigates how relative frequencies can be used to estimate probabilities. So we're going to be working through an example about tossing a coin, and we're going to be using what's called the relative frequency, which is similar to an experimental probability to get close to estimating what the theoretical probability of something would be. All right, so you will need to make sure that you get a notes page from your teacher. There are some tables and graphs in here that will be helpful for you as you work through this lesson. So make sure you get that from your teacher. Beth tosses a coin 10 times and records her results. Here are the results from the 10 tosses. So here's a table showing what she got each time she tossed the coin. The total number of heads divided by the total number of tosses is the relative frequency of heads. It is the proportion of the time that heads occurred on these tosses. The total number of tails divided by the total number of tosses is the relative frequency of tails. Beth started to complete the table on your notes page as a way to investigate the relative frequencies. For each outcome, the total number of tosses increased. The total number of heads or tails observed so far depends on the outcome of the current toss. Complete the table on your notes page for the 10 tosses recorded in the previous table. So on your notes page, we're looking at example 1. So here's the work that Beth started with. So on her first toss, she had an outcome of heads. So her total number of heads so far is 1, and her total number of tails so far is 0. So to find the relative frequency, we're taking how many, or our total, and dividing it by the total number of tosses, which 1 divided by 1 is 1. And then over here, we didn't have any tails, so 0 divided by 1 is 0. So trial 2, she got a head, so now she has a total of 2 flips that came out as heads. So 2 divided by 2 total flips was still 1. And again, we still have 0 tails. So on toss 3, she does get a tail. So the number of heads stays the same, but now it's out of a total of 3 tosses. So this probability or this relative frequency changes. And now we have 1 tail, so we have 1 out of 3, it's 33%. So on her 4th toss, she tosses a heads. So that's going to increase that head by 3, and the tail is going to stay the same. I'm going to go through and list these, and we'll go back and do our relative frequencies. On toss 5, she had another flip that came out heads, so it would be 4, and this stays the same. 6 was another heads, so 5, and we still only have 1 tail. On 7, we get another tail, so our head number is going to stay the same, and our tail number is going to increase, so up to 2. Okay, so toss 8, she gets another tail, so that one stays the same while our tail increases. On 9, she gets another tail, so stays the same while tail increases. And then on her 10th one, she gets a head, so this increases to 6, and this stays at 4. So I'm going to go back through and find my relative frequencies. So I'm taking the total number, so 3, and I'm going to divide it by the total number of tosses, which when I divide this out is 0.75. Again, we're taking how many we have out of 4 total tosses, which when I divide is 0.25. All right, so our next row, we have 4 out of a total of 5. When we divide is 0.8. And then 1 out of our total number, 0.2. Row 6, 5 out of a total 6 tosses. When we divide is 0.83. And then 1 out of 6 is 0.17. All right, row 7, 5 out of a total of 7 tosses is 0.71. And then 2 out of 7 is 0.29. Row 8, 5 out of 8 tosses, 0.63. And 3 out of 8, 0.38. And these are rounded, just so you know they are rounded. 9, we have 5 out of 9 is 0.56. And 4 out of 9, 0.44. And then 6 out of 10 is 0.6. And 4 out of 10, 0.4. All right, so let's go back. And we have a question now to answer. It says, what is the sum of the relative frequency of heads and the relative frequency of tails for each row of the table? So if we look in our graph or table here, if we were to add these two together all the way down our table, if you notice, these all add to equal to 1. So we could show, like for row 1, we had 1 plus 0, which would give us 1. And then row 2, again, we had 1 plus 0, which gave us a sum of 1. Row 3, we had 0.67 and 0.33, which equals 1. And then this continued all the way down. So the sum of the relative frequencies is 1. Alright, so the next question says that Beth's results can also be displayed using a graph. Use the values of the relative frequency of heads, make sure we're using the head column, so far from the table in part A to complete your graph. Okay, so we're going to use this table and we're using this heads column and we're going to graph these relative frequencies. Now I have already filled out this graph. So I'm going to show you what this looks like. I haven't connected the dots yet. So I went through and at 4 it was 0.75, so at 4 I went up to 0.75 and put a dot. So once you have all of your dots, I want you to go ahead and connect all of those. So this is what that data in the table looks like. Okay. All right. Let's look at our next question here. It says, Beth continued tossing the coin and recorded the results for the total of 40 tosses, and here are the results for her next 30 tosses. Now, on your notes page, we're going to fill in a table that's going to help us make a graph here in just a minute. So if we take a look at this table on part C, we're doing total number of heads so far, and then we're going to find the relative frequency. So at 1, we know that we had a total number of heads was 1. At 5, it was 4. At 10, it was 6. And so now we need to go to the new graph that they gave us. Find my paper here. Okay, so we're going to count, we're starting at 6 and we're going to 15. So I'm going to stop right here. So again, we're starting at 6. So here would be 7 and 8. So after 15 tosses, we've seen heads show up 8 times. All right, so now we're going to go to 20. So 20 is all the way to here. So 8, there's 9, 10, and 11. Okay, we're going to go 25, which is right there. All right, so 11, there's 12, 13. Okay, and we're going to go to 30. All right, so 13, 14. To 35. So 14, there's 15, 16, and 17. And then all the way here to the end, 18 and 19. All right, so I know this table is a little small, so I'm going to try to zoom in just a smidge so you can see this a little bit better. Try to get it without it all going off the screen. Okay, so now let's find our relative frequency. So we had 1 out of 1, 1 out of 1, which when we divide is 1. Okay, so we had 4 out of 5, so 4 out of 5, which when we divide is 0.8. We had 6 out of 10, which is 0.6. Okay, then we had 8 out of 15, which is 0.53. We had 11 out of 20, which is 0.55. 13 out of 25, 0.52. 14 out of 30, which is 0.47. 17 out of 35, 0.49. And then 19 out of 40 is 0.48. Okay, gonna zoom back out here a little bit. Alright, so the next part says to use the relative frequency of heads so far from our table that we just made to complete the graph on your notes page. So on your notes page, you have this graph that you're going to fill out, which I have already filled out all of my dots. I just haven't connected my lines, so go through and place all of your dots, and then we're going to connect these. And when you connect these, it doesn't have to be perfect, just trying to get the general idea of what's going on in our graph. And now let's use our graph and let's answer a few questions. So it says, what do you notice about the changes in the relative frequency of the numbers of heads so far as the number of tosses increase? So as the number of tosses increase, what do we begin to notice about our graph? I hope you begin to notice that this kind of starts to level out as we start to approach this line right here. As you can tell, we took a big dive, we stayed above, and then we dropped down low, and we're kind of hovering right around it. So we could say the relative frequency starts to level out, which means like a straight line around the number 0.5. So as we're approaching that 0.5, it starts to level out. Okay. If you toss the coin 100 times, what do you think the relative frequency of heads would be? Now, because that graph, as the more we do, starts to really go close to that 50 line, I would guess that it would be very close to that 0.5. It might be a little above or a little below, but it's going to be very close to the 0.5. So it would be very close to 0.5 because in the graph it had already started to get close, to 0.5 after 40 tosses. Okay. Based on the graph and the relative frequencies, what would you estimate the probability of getting heads to be? So again, because we're getting close to that 0.5, I would estimate that probability to be 50% or 0.5 because that is where the graph starts to level out. Oops. Okay. How close is your estimate in part H? Oh, you don't have a part H, sorry. So how much close is our estimate to the theoretical probability of 0.5? So I think our estimate is very close. We got very close to that in our graph. So our estimate is close. Would the estimate of this probability have been as good if Beth had only tossed the coin a few times instead of 40? So if we go back and look at our two graphs that we made, this will kind of help us answer our question. So our top graph was just the 0.5, which, as you notice, those took there are lots of fluctuations in that line. So if she had only tossed it maybe 4 times, we wouldn't have a very good read about where that would be. So as she tosses it more, that's when we start to get a better idea of where that frequency is, or that probability. So no, our estimate wouldn't have been as close. The more trials and data we have, the closer our relative frequency would be.